in this question, I am trying to implement and design a least frequently used cache. What is least frequently used cache? Least frequently used cache basically keeps the most used elements, most used case in a system. For example, and it has also capacity. For example, capacity is 3. A is used 3 times, B is used 4 times, and C is used 2 times, right? And I made a put operation, and then I assigned a value to D. For example, I assigned a value to D. What happens? We have to add D to system. Okay, that's for sure. Before adding that element, I'm looking at capacity. If the number of elements in cache is equal to capacity, yes. So we should remove the least frequently used ones. Which one will we remove? We will remove C, which is only used 2 times. And add D. What if A and C is equal to 3? And okay, and now I'm added A, added D. Which one will I remove from the system, from the cache between A and C? I will remove the least recently used ones between them. Least recently used. Okay. So actually it gives me some idea. Okay, I should find the least frequently used case, and if there is an equality, I should use the least recently used. First least frequently, and second least recently used. How can I implement? Maybe I can keep frequency. I can keep least recently used cache actually for each frequency when I use it. For example, when I put an element to cache, okay, for each level, for each frequency, I can keep a cache, and I can add those elements to cache in that level. Okay, let's go from an example. Cache size 3, capacity is 2. Okay, I put 1 to 1. Actually, I should first have a map, right? Is the integer and this is the queue. K will be level, because for frequency values LRU, least recently used cache, and I will find LRU from here. Okay. And I want to implement lazy removal in queue. However, will it be problematic in this system? because there can be an element in multiple levels, right? Okay, I added an element, used A, level 1, used A again, it's in level 1 and 2 because it's in frequency 1 and frequency 2. Used A again, level 1, 2, 3. And then I remove A from cache. I have to, okay, now remove all elements in A level 1. Remove all elements in level 2 and remove all elements in level 3. No, not all elements, until A. Because after I removed A, it's done. But why does it work? Why I'm removing all elements until this? And why am I removing all elements until A? Because I'm removing the least frequent used element, not A, not until A. There is no specific A. Actually, I know that first I added an element, first time I used, now it's in level 1, cache level 1, because frequency to LRU, and I added this Q A once. This is the character, and then I want to use that element one more, and I know that its frequency is 1. So actually I'm using the element to frequency. Okay. Let me write it. Is an element, K is integer, so it's not A actually, it's an integer. Okay. K to frequency. So in this map I know the last frequency, how many elements in the system, how many A is in the system. Okay, it has to be, K will have to be integer, but for the understand I'm saying A. First I used A, it's in level 1. Now I use A again, so I have to add the add the Q in level 2. I use A, I'm at the level 3. So, and for also it can be valid for B. Use B, level 1, use B, level 2. And A is first, B is later, right? Actually Q1, A first, 1 first, then 2. Q2, 1 first, then 2. Q3 is only 3, only 1. Okay, so I start from where I left. For current level, start from the 1. Okay, I can just start from 1, because if I remove an element, it means that I will add a new element after that. So actually the level will be reset to 1 because my level minimum level keeps the minimum level information. I added 1 2 1 2 1. No, normally this is 2, this is 3, 1 is in the level 3 and 2 is in the level 2, and I start from 1. There is some add operation from here. 1 2 remove them, 1 stop here. Okay, so start from 1. I'm removing 1, right? Yes. I'm removing 2 again. Yes. Because why removing and continuing? Okay, I removed 1. Is it the last element in queue? Is it the biggest queue element? I'm just looking at key to frequency. If once A's frequency, okay, if A's frequency is 1, no, it's 3, so I'm removing that. Is B's frequency is 1? No, it's 2. Okay, Q can stay. Now I'm at Q2. Is A is here? No. A level is 3. Is B's level 2? Yes. It's the valid element. It's not invalid ones, such as the older ones. So I'm removing B, and Q removal operation is complete. Now I can add the new element, for example C, to Q1. Okay. For get operations, I also have to k value pair. I have to keep the k value pair. Is it enough? Is it enough? Okay, key value gives me the values of that element. K to frequency is giving me the current frequency of the K. And frequency to LRU is I'm finding a Q from frequency, for example. Okay, let me try for in a real example. I have 3Q and I have capacity. Now I start from LFU cache. Capacity is 2. Okay, I said capacity is 2. I put 1 to 1. Okay, 1 to 1. Kate value will be updated. That's for sure. Now I'm looking at the current size. Okay, before adding them, I'm looking at the current size of the system. I can just looking at the size of K because it keeps only the Q's case once. Is the size equal to 3? No. Okay, start from 1 get. Okay, put 1 to 1. That's the first operation. Is the size of K to value 2 equals to capacity? It means that it's full. No. So what do I do? I'm just putting that element to Q, right? Putting that element to Q. I don't have to remove anything. Just put but I shouldn't forget that even the capacity is full, one is already in the cache. I'm not introducing a new key to the system. I'm just increasing the number of usage of a key which is already in the system, so I don't have to remove anything. If the element is new and the capacity is full, now I should remove one element from cache. Okay. If the size of the k to value equals to capacity and k is not in k to value. Okay. K is not in k to value. If one of them is no, if actually, let's say, no. Okay, let's start from no. So, just add new elements without removing that. Or if yes, what I'm doing is just remove from queue what I'm removing from the queue. Actually, I'm just removing the least frequently used element and then add element to queue. Okay. What I'm adding to queue is k. And then also I can add the element to k to value map also. However, in remove queue function, I should also remove the alt value. Actually, first find LFU K, right? K is, I'm finding the LFU case. Then I'm removing that key from k to value here. Just say remove k. And I will add k to queue. Okay. So it's clear to me. Okay, no matter what, I'm adding element to queue, and I'm also adding that element to k to value pair. Okay, for get what I'm doing, there is nothing to remove, but yet can be also invalid. So is the key actually in k to value? If no, return -1. If yes, I'm just implementing a new function, use k key. I'm using the k once, one more. Or just I can use add q function. Because using put or get is the same in terms of cache. Yeah, in get I'm using the existing. In put I can use the existing key or introduce a new key, but that's not a big deal. Okay. Find LFU key. So actually what I am doing in here, my job is with the queue. So start from 1 while true. Okay, start from level is 1. No, I'm traversing each level, right? Until something stops me. Start from the level 1. Now I'm getting current queue. Get level. Okay. And I'm traversing all the elements in queue. Okay. While queue that is empty actually. When queue is not empty, next key is what? The one which will be removed is q.poll. Okay, I removed one key from q. Is it the one that valid? To understand if it's valid, I'm just looking at the real frequency of this key. Real level is what? K to frequency that gets K. Actually real fract, I can just say. If let me say if frequency is not equal to real frac, what I'm doing is just remove that element. First, only from frequency to LRU, right? Frequency. Okay, just I'm not doing anything actually. I already removed from poll. So actually I'm nothing else. Or instead of just look at the equality. If equality, so I find the real element. I should stop here. Actually, I will return this key. I will return next key because I find the real one, and I cleared the queue actually. Do I have to do anything else in here? I have frequency to LRU. Okay. Just remove. Also remove from key to frequency, right? Because I removed the element from queue completely. And I will remove k to value outside of here. Actually, it seems correct to me. I know that each level has at least one element, because if the valid k is at level 3, also it's in the level 2 and level 1. So each level is true. And I know that this while loop do not change the time complexity, because the number of traversal is not more than the number of adds, because I'm only traversing the elements that I already added, and each level has at least one element, so it's not a problem. Okay, Now, what's next? What's next? I find the LFU key and I remove from value, I remove from locate frequency, and I fix the Q. Okay. Now it's okay. I implemented LFU and implemented put get, and now I have to find the add Q key. Actually, I know that the element, now I should first look at its frequency to find its, to reach its LRU. However, at the end, and now, okay, so K to value update is here, so I'm not dealing with that. I'm just adding K to Q. Okay, now I have to find this frequency. Old frequency, because it will change. K to frequency dot get. Okay. However, as I said before, it may be put operation and the frequency is never used. I'm introducing new element maybe. So K to frequency may not contains K. So if I'm introducing the first time, its old frequency is 0. So I'm saying get or default. If K is here, get value. If not, get 0. Okay. So the new frequency is old frequency plus 1. I'm doing it because I don't want to confuse. Now I find the old frequency, I find the new Q frequency. Now what do I do? What do I do? I know the old frequency, I know the new frequency. So actually, if the old frequency is 0, I cannot remove it from the K to frequency. But okay, I will update K to frequency. K to frequency. Pot K new frequency. Okay, I updated it. Now the only thing that I have to update is frequency to LRU. Q, it's not character, it's integer. Q to integers. LRU, current LRU is frequency to LRU dot get key. What if K is 0? Actually, I cannot get anything. So if k old frag not equals 0, I'm doing that operation. Yes. Okay, I get the old k. However, I'm not doing anything with the old frequency. Why? Because I will remove it when I'm finding the LFU case. Because if it's not valid, I'm just removing and continuing. I'm not removing it right now. Instead, I will remove in the find LFU case, because I know that it's not valid right now. I can find it from the kth frequency and the current LFU frequency. If they are mismatches, so I will remove it in the find LFU case function. So I'm not doing anything with the old frequency, just k2 so I just this old frequency, new frequency. Okay, so I will add the element to new frequency LRU. However, maybe it's not introduced. So if frequency dot to LRU dot get contains k, actually if it's contains k new frequency, not contains, so I did not introduce a LRU for this frequency, so just add LRU that add frequency, so frequency to LRU dot put new frequency to new Q, which is linked in Java. Okay. Now it's okay. Frequency to LRU that put. Okay, I know that it's already. It's here. New frag. Now I got the new LRU and LRU that add what I'm adding is the new frequency, not new frequency, is the key. Okay, I think the queue adding operation is okay, no problem. So input, yes, I'm checking this because should I the key I introduce is not in cache, and the capacity is reached. So find the key to use list from here. Let's look at this. Start from frequency 1. For each frequency, let's check. I know that it's already inside because I added queue input. Okay, is the queue current queue actually this is? Yes, current queue is not empty. It means that there is an element. So remove the key. So let's check is the key is valid. The real frequency is k to frequency. My current frequency is the level, which is frequency. If they are equal, I reach to the real k, the valid k, and I'm removing from frequency because all example of it is removed. So I just remove k and return that k. That key. Okay. And after returned, I'm adding and I'm removing that element from value and introduce new element to queue, and I add its value to put. In get, it's also, if not, is in the cache, just return -1. If yes, and return that. Add the element to queue. Yeah, so it means that increase its frequency by 1. And return k to value that get key. Okay, now let's look at the key. Add queue key is working correctly. Old frequency is k to frequency to get our default k0. Yes, I'm trying to find the old frequency. If it's in k to freq, return 0. If not, return 0 because old frequency means 0. If it's inside, just get it. New frequency is old frequency +1. updated k to frequency with the new frequency. And get LRU of the new frequency. If not, I just add new one. I get this level, the next level's LRU, and add this key and return. Okay, I think it should work correctly. Let's try it with an example, so everything will be clearer. Okay, now let's say I'm just removing them, or add here. While loop is here. Okay. LFU cache capacity is 2. Capacity is 2. Just add capacity is 2. Put 1 to 1. Okay, put 1 to 1. Is the size of k to value equals to capacity? No, it's 0, so I'll just pass it. Add q key. Okay, let's start with add q. Old frequency. It's not inside. So new frequency is old frequency plus 1, which is 1. Yes, 1 to new frequency, k to frequency, k1, new frequency is also 1. Okay, 1 to 1. Frequency to LRU is not contains k, no. Okay, add 1.q. I'm just saying q is this. Now get this q and offer that k. K is 1. So let's offer this k1 and return. Okay, I added q, k to value, put 1 to 1. Yeah, it's value 1, right? 1. Okay, 1 to 1. Now I put 2 to 2. Is the size of k value equals to capacity? No, 1. This size is 1. And this is 2. Add qk. What's the key? 2. Old frequency is 0. Not, there is no 0. New is 1. There is no old frequency, so it's 0. It's 1. Put 1. K is 2. New frequency 1. Just add 2 to 1. If the frequency to LRU, frequency to LRU contains k new frequency, which is 1. 1, yeah, it contains. So just pass it, just get it, and offer also 2. Okay, return. And also add k to value pair. 2 to 2. And get 1. Okay. If k is in the k to value, yes. So just pass it. return k to value dot k. But first add q. Let's work with it. K is 2. Old frequency, what is this? It's 1. K to frequency 2. K to frequency is 2. Is 1. New frequency is 2. K to frequency is 2 to 2. Right? No, I'm getting 1. Sorry. I'm getting 1. Okay. Sorry. One is indicate value, yes. Now let's look at k to frequency dot get. 1 is 1, so new frequency is 2. K to frequency dot put 1 to 2 is frequency to LRU that contains k1. No, new frequency is 2. No, it's not includes. So for 2 add 1 new q. And now get it and offer k1. Okay, now it's okay. Now it's okay. Then what do I do? Okay, k to value k. Okay, k2. I just use get, and I'm returning k to value get, which is 2. Is it 2? 1. Sorry, I'm just getting 1. I'm doing the same mistake again. And I'm getting it 1 to 1. Return 1. Yes. Now I'm putting 3 to 3. 3 to 3. Is the size of k to value equals to capacity? Yes. Equals to capacity? Yes, capacity. And k is not into k to value? Yes. Now I should find the removed case from the find the LFU case. Okay. Let's go here. Let's start from frequency 1. While true, get the current Q is this. Yes, current Q is not empty right now. I'm polling, so first poll is 1. What is the, not to forget, next here is Q dot poll. Let's poll 1. Real frequency is 1 to 2. Real frequency is 2. Is real frequency is frequency. What is frequency? Freq is 1 now currently, not equal. K to frequency to remove next k. No, it's not equal actually, sorry. They are not equal. So let's in the while loop again. Yes, current key is not empty. 1 is removed. Now it's in this. Now it's time to. Now I'm in the while loop again. Next key is 2. Just hold it. So this will be empty. Now real frequency is k to frequency dot k. Real frequency is get k to frequency dot k. What's k to frequency of 2 is 1. It's the real frequency actually. And current level is 1. Also, if they are equal, yes, they are equal. So k to frequency that remove the next key. What's 2? K to frequency is 1. It's still valid real 1, so I'm removing it completely. And I'm returning that 2. Okay, LFU returns where okay, we came from here, and it returns 2, and also k to value will return 2. Okay, now we get rid of 2 completely, and k to value dot put k is 3, value is 3. Put k to value dot put, and now first I should ask you 3. Okay, it's 0, it's 1, new frequency is 1, k to frequency dot put 3 to 1, 3 to 1. If not frequency, if frequency to LRU is not contains k new frequency, what does it mean that? K to frequency dot put k and new frequency. Yeah, we see that. Uh, 3 to 1. Yes, I put it. Now frequency LRU that contains k new frequency. Yes, 1. Actually, I did not remove that. Maybe I should remove that, because I use to 1 million times, there will be 1 million Q. Oh, but maybe not now. Okay, not now, not now. If I want to remove that when it's empty, where should I go to? I should remove at the end of while loop. Okay, I just can remove it when it's empty, so it will be clearer. Now where did I left? Now I'm adding 3 to 1 to Q. Okay, K is 3, new frequency is 1. I added if it contains. Now what I'm doing is adding 1 to new linked list. Yes, I'm adding 1 to new linked list, and get it and offer the current K. Okay, I added K3 and return. K to value that put K to value. Okay, K is 1, value is what? Sorry, K to 3, value is 3 from here. Okay, let's get get 2. If it's k in kth value, no, return -1. Okay, I can just return -1. And now I'm doing the get operation for 3. Okay, if the k is in the kth value, yes, add q3. What is the kth frequency of 3 is 1, new frequency is 2, k is 3. Okay, I put 2, I made it 2. If frequency, the LFU contains k new frequency, yes, it contains k, yes. So just get that LFU and offer the new k, which is 3. Okay. Now I'm offered that LRU 3 to 1, and I'm returning Q, and in get, and I'm returning K to value that get 3, which is 3. Okay. Now I'm putting 4 to 4. Okay, is the size of K to value equals to capacity? Yes, and K is not indicate value. 4 is not indicate value. Yes. So first I should find LFU case and then remove it. Okay. Let's start from frequency 1. By the way, did you see that when I'm adding 3, I left a sign for each add. First add 3 to here, then here, then here, and then I will remove 1 to 1. So actually, for each remove operation will not be more than the add operations, more than the total of the add operations. So actually, in average, it does not break the complexity more than 1. For example, I add 2 I add 1 to here, then 1 to here, then I add 2 to here and 2 to here, right? And remove 2 from here, 2 from here, 2 from here, and 1 is still there, and add 3, and starting from for loop, I'm actually not passing all. I'm hitting element for each while loop, each for, because while loop will not be past the last 3, and I know that 3 gives a frequency to all queues until the last queue. So it's not breaking the time complexity. Okay. So LFU K frequency is 1, right? While true, frequency is 1. Yes. Okay, start from the first frequency. Just get it. Is okay. Next key is q.poll. Next key is 3. Next frequency this real frequency. What's the real frequency of 3? Is 2. We get it from, where do we get from? We are not getting it from here actually. we are getting it from here. The real frequency is 2 sorry, 3 of 3, the real frequency of 3 is 2. They are equal? No. We are at no, actually at the first level. So we remove and let's continue. Now this queue is empty. Okay. Queue is empty. I'm going to out of the for loop and current queue that remove frequency. Okay, I'm removing it completely. Now I'm at the increasing the frequency level by 1. Now I'm at the current queue at level 2. Yes, I'm getting it. I'm sure that there is a current queue at level frequency. Current queue is empty. Is the current queue is empty? No, actually while is not empty. One, two, three. Next key is queue.poll. The first one is 1. I just removed 1. K2 frequency dot get 1 is 2. Is it equal to current frequency? Yes. So I'm also removing it from the K2 frequency. What is the K2 frequency? What is the K2 frequency of 1 is 2. I'm removing it. Yes, it's the valid K. It's the, I know there is no more 1, and I'm returning 1. Okay, K2 value that remove 1. K2 value that remove 1. I removed it and introduce 4. Now I'm adding Q4. Yes, no. New frequency will be 1. 4 to 1 will be new K2 frequency. If frequency to LRU dot contains K. No, actually we removed the ones. New frequency is 1. So let's create a new queue. 1, 2, queue. Yes. LRU dot offer what? 4. And return. Put 4 to here. Now I'm saying get 1 is 1 here. Now return -1. Okay, let's get 3. Is K indicate value? Yes. Add to K Q3. Old frequency of 3 is 2. New frequency is 3. Put 3 to 3 K to frequency. If it contains K new frequency, frequency to LRU that contains K new frequency. No, there is no Q with 3. Yes, put new linked list and add 3 to here also. And I'm returning and return 3 to 3, which is 3. And for 4, I'm doing the same operation also for, and I'm returning 4 from K to value 4. So actually that's the backbone, and the example worked correctly. Whew. Now let's implement this with a code. Okay, what I have, I'm implementing it outside constructor. So frequency LRU, K to frequency, and K to value. Right? And also I also should save the capacity. And in constructor I should define them. New hash map, actually all three of them is hash map. Yes, and remove them. Okay, I implemented the constructor, right? So let's go to which part? Get, put. Okay, let's start with get, which is the short one. Is the K in get? Which K? K to value. If K to value that contains K. If no, return -1. If yes, okay, if not, return -1. Add q.key. Okay, I will define a new function that add q.key and then return k to value.k. Okay, it's great. Now I should implement the put also. I will go here later on. Is the size of the k to value equals the capacity. K to value, okay, if k to value dot size equals to what? K? No. Capacity. What's the capacity? Is this capacity? And what's the next? K is not in the K to value, I think. Yes, K is not in the K to value. Okay, not contains K. It's not. If yes, removed K will be defined LFU K, then K to value dot removed K. Okay. Then I will add new element to queue and K to value map. K to value dot put K and value. Now I need helper functions. Find LFU key and add Q. Public void add Q in K. Also I need public int find LFU keys. And it. Okay. Now let's start from add Q. Let me try to think from my mind without looking at my notes. To add Q, get its frequency, from its and find new frequency is +1 and add it to LRU. If there is no LRU, create them and add it to LRU. Okay. Add Q. Just copy and paste. Yes, alt frequency, get default new frequency is 1 plus. K to frequency is K to new frequency. Not contains K, new frequency. There is no LRU. Okay. And also for the find LFU case, what I'm doing, start from 1 to visit all queues. And in Q in all elements, let's check it's the valid one. If not, just continue to remove, and if it's valid, return it. Yes, alt frequency, new frequency, yes, K frequency dot put new frequency. Actually, I don't have to do that. Do I have to do that? No, it's just find the LFU case. Yeah. If not contains, what I'm doing here is I'm just new frequency. Not copied to the right one. Okay, sorry. Start frequency from 1. While true, get the current queue. If the current queue not is empty, while the current queue is not empty, get K. Get real frequency. If the current level is a real frequency, it means that it's valid element. Remove from K to frequency. Am I doing that? Don't have to do that. It's not just finds the LFU case and return it, because I will update K to frequency in here. Okay, let's try. I know there's some mistakes in terms of syntax. Yeah, integer frequency. Current queue will be here. Reach K. It's the next key. Which frequency? Yes, this frequency. I updated it. Let's try it again. Unreachable? Yeah. I know. Great. Oops. Oh. I missed the point. Oof. What did it miss? Okay, maybe it forgets to remove K to value. Although it should remove. Yes. Return K to value. Not contains K. Are there any other test cases? I don't know, man. Let's print states of what. Let's print K to frequencies. For each operation. Let me try it. Okay. I had 8 1. I used 8. Put get. But get is not in queue. Okay. 10, 3, 6, 10, 9. 10, 3, 6, 10, 9. Why it updates? Put 5 puts, okay. 9, 3, 6, 9, 10, 9. 13. Can I get 13? No, so it 1, 2, 3, 4. 1, 2, 3, 4, 5 operations. And I'm doing, no, actually it's not going here, so it's not printing. It's okay, there's no problem with it. Let's say size of it is 1. Will it work correct again? It works correctly. If the size is 2, there is a problem maybe in cache logic. What? Did you update it? Yes. LFU cache size is 2. This capacity is 2. Okay, the value is size. Isn't remove operation works correctly? It doesn't remove frequency. Oh, because we removed that. Oh. Oof. Oh, no, will it work? Let's remove print lines. I forget to remove also decay from frequency because I removed the element completely, so I should remove it from frequency. These small pregnants are removed. Yes, it returns. I think I should solve more questions like this. Yes, I'm not using that. It's one of my friends is using. Okay, now let's try. Now I mixed right, but let's ask this ChatGPT. Did it like my solution? I think there is another solution. Instead of using this lazy solution, maybe I can remove the frequencies in place. I think it maybe did not understand my solution, but I think my solution is O1. It just didn't understand my solution, I think. Oof. I think they should have it should calculate the time complexity. Can't they do that? No. No, chat didn't understand my solution. It's impossible. No. Yes, R is complexity. Okay, it's exit limits. Let's remove them and ask again. Yes, all and as you see, it's clear. I think it's not correct. It simply did not understand my solution. You can't, it cannot be null because if you, to get something, first you should put. Can it call get before calling put? Add queue. Find an LFU case. To make LFU work, to remove something, first you should reach the capacity. And capacity is not 0, at least 1. Okay, let's say capacity is 0. I think it even won't work it, because capacity should be at least 1. Yes. So you cannot work LFU with an empty. There is at least one element in system, and that one element has a sign, is also in the first queue in map. So you can just start from 1. Current queue dot remove frequency. Sorry, but it's correct. I'm completely removed the bucket. Current yeah, it's correct. No, it's not correct. It's the lazy. I'm removing them lazily. Okay. Correct. Fincrack tracing is unnecessary, as it only removes when capacity is reached, and to reach capacity there should be at least put operation between removes, and when you start putting, it starts at first queue, and when you call same element more than once, it will be also in Q1, Q2, etc. Loading go lazily. didn't understand my solution. No, it won't, bro. No, bro, you. It's impossible, bro. It's impossible. Scene list. Kalıntı ne? What's meaning kalıntı? Residue. Okay, just residue. Yes. V yes. Okay, he's right maybe. Maybe I should update. How can I change no it's No, bro, it cannot be. He just did not understand my solution. Okay, but I understand. Yes, there can be some residues in caches, old caches, so it can maybe increase the space complexity. It may bound to the total add operations. For example, I added first and then removed. I added, then removed. I added 10 to the power of 5 times and removed, and then I made one insert operation and made 10 to the power of 5 get operation. The space will be grow with get, and space will be grow with get. However, I can make it that I can bound my space with just insert operations, so we can actually adjust it. It won't be a problem in this question, because get and put operations is bounded together. However, let's think about how to modify this solution to I should remove it from old. Choose. Can I do that? If I want to do that, I should change the structure completely, and I should rely on double linked list, because I can't just remove an element from a queue. It's not possible in O1. So I think my solution is optimal and correct, but maybe in next I can implement a different approach, which is double linked list. Thank you for listening to me. I know no one is listening until here, but I'm trying to create a my English is not well. Even I came here 2 months ago. Routine, yes, it's also Turkish. I'm trying to create a routine and try to obey that. That's why. Okay, thank you for having me. Goodbye.